This is part 2 for the review for series test number 2. This is starting the section on the ratio test. One way we know to try the ratio test is we've got different types of functions here. We've got n to the 7th, which is a polynomial, and 7 to the n, which is a exponential function. So for the ratio test, we take the limit as n approaches infinity of the absolute value of, we put the original on the bottom, and on top we add 1 to all the n's. Okay, then we have a fraction over a fraction, so we multiply by the reciprocal. Now we can't do anything with the polynomials. N plus 1 and n don't cancel out, they're not the same, but we can cancel out all the 7's except for one of them on the bottom. Because we had 7 to the n plus 1 on the bottom, 7 to the n on top, so there's 1 left on the bottom. And that leaves us with n plus 1 to the 7th over 7 n to the 7th. The powers are the same. We have n to the 7th and n to the 7th. So we just use the coefficients, which would be 1 over 7. And the rule for the ratio test is that if your answer is less than 1, it converges. Okay, next one. Again, we've got factorials and exponentials. So that would give us a good reason to think to use the ratio test. We put the original on the bottom. On top, we add 1 to all the n's. Then we multiply by the reciprocal. And it is possible for us to cancel out the 3's. There's 1 more on top than there is on the bottom. So all the ones from the bottom go away and just all but 1 on top goes away. We can also do that with factorials. When you're reducing factorials, you leave the smaller one alone. That's n plus 4. And you rewrite the bigger one as the smaller one times that. So if you think about it, say n is 1. Then this was originally 5 factorial, which means you multiply 1 through 5. And then n plus 5 was 6 factorial. So that means you multiply 1 through 5, or 1 through 6, excuse me. So this covers the 1 through 5 times the 6. So it's the same as what we started with. Now n plus 4 factorial cancels out. That leaves us with 3 over n plus 5. So here the limit would be 0. As long as your answer is less than 1, that means your series converges. Okay, next up we get the limit as n approaches infinity. We put the original on the bottom. On top we add 1 to all the n's. Then we multiply by the reciprocal. Okay, the 3's we can cancel out all of them except for 1 on top. There's 1 more on top. The polynomials we can't. So we go ahead and multiply this. We get 12n squared over 4 times n plus 1 squared. The powers are the same. They're both n squared. So we use the coefficients, which is 12 over 4, which reduces to 3. Now since our answer is greater than 1, we get diverge. Number 4. Converge or diverge. We get the limit as n approaches infinity. We put the original on the bottom. On top we add 1 to all the n's. Multiply by the reciprocal. Okay, we can cancel out all the 9's except for one of them on the bottom. There's 1 more on the bottom than there is on top. And the n plus 1 factorial can be rewritten as n factorial times n plus 1. Because that would cover all the numbers 1 through n plus 1, which is what we need. Then the n factorials cancel, and we're left with n plus 1 over 9. Now this limit would actually be infinity, because the bottom is just 9, the top is going to get huge. So since the limit is infinity, that's clearly bigger than 1, so this one diverges. Final example for the ratio test, we have converge or diverge. We want to do the limit. As n approaches infinity, we put the original on the bottom. We add 1 to all the n's on top, and then multiply by the reciprocal. Okay, first of all, the 2's may look different because of the -1, but it works pretty much the same way. There's one more 2 on the top than there is on the bottom, because the top has n 2's and the bottom has n minus 1 2's. So there's one more on top than there is on the bottom. So we can cancel all the ones out on the bottom and all but one of them on top. Just like last problem, we can change n plus 1 factorial to n factorial times n plus 1. The n factorials cancel. That leaves us with 2 over n plus 1. The limit here is going to be 0. Power is bigger on the bottom. And since 0 is less than 1, we know the answer is converge. Okay, now switching gears to the root test. You may be able to do some of these with other ones, but for the sake of practice, I'm going to do the root test. So we do the limit of the nth root of 3/2 to the n. We just do the nth root of our sequence there. The nth root cancels out the n, leaving us just 3/2. Just like with the ratio test, if the answer is larger than 1, then our answer is diverge. And you could probably tell that since this was also a geometric series. Okay, so again we get the limit as n approaches infinity of the nth root. This one you also do the absolute value in case it comes up. The nth root cancels out the n, so we get, or the nth power that is, so this cancels out this, leaving us 2n over 5n minus 1. The powers are the same, so our answer is 2/5. And since that is less than 1, that means we converge. For number 3, we have the limit as n approaches infinity of the, nth root of 1 over natural log of n to the n. So the n cancels out this n, leaving us just 1 over the natural log of n. As we take this limit, 1 is going to stay 1, the bottom is going to go to infinity. That means the limit will be 0, and since that is less than 1, our answer is converge. Okay, we get the limit as n approaches infinity of the nth root of the absolute value of 4n minus 3 over 3n plus 5 to the n. The nth root cancels out the nth power, leaving you 4n minus 3 over 3n plus 5. The limit here will be 4/3 because the powers are the same. Since the answer is larger than 1, by the root test we know that means that the series diverges. Finally, on the root test, we have the limit as n approaches infinity of the nth root of the absolute value of n plus 3 over n to the nth. The nth root cancels out the nth power, leaving us n plus 3 over n. The limit here is 1. So there may be other ways to figure out the answer, but as far as the root test is concerned, it is inconclusive. The root test here is inconclusive because our answer is 1. Okay, I'm going to go through the anything goes series now and go pretty quickly through these. So first, converge or diverge. This is an alternating series. The way you do alternating series is you take the limit without the -1 to the end part. If you get 0, like you do here, then that means the original series converges. Remember, we're not talking about what this series does, we're talking about what this series does. So the fact that this goes to 0 proves that the original converges. If you get anything other than 0 on alternating, it diverges. Okay, this one is also alternating, so we do the limit as n approaches infinity of the function without the -1. So this one also gives a 0, so it also converges. Okay, this one we need to estimate the sum, so the error is less than 0.001. So to do this, we go to y equals, we plug in this equation. If you want to use the -1, you can. It won't make any difference because you're looking at absolute value anyway. And we're looking for the first time that this goes, that either equals 0.001 or goes below 0.001. So I just had some random numbers up here, so it's going to be above 365, so Let's try, say, 400 maybe. Okay, not there yet. Let's try 450. Not there yet. Let's try 500. Sorry, that wasn't right. 500. Okay, so it's going to be somewhere around here. Looking at that, that one actually falls below. So it's going to be right around 500. So let me back up and try 498, 499, and then 500. And again, we're looking for the first time it either equals 0.001 or falls below it. Now you need to go over and highlight it like I have here, and then look at the expanded version on the bottom. Okay, so this is still above 0.001, but once I go down to 500, it's now below 0.001. So I don't want to include the 500 term, but I want to include everything that comes before it. So I don't want to use 500, but I do want to use everything before it. Looking back at my original, I see it started at n equals 1, so I want to use 1 through 499, so that will mean 499 terms. Okay, this one, we take the limit, it's alternating, so the limit as n approaches infinity. Without the -1 part, we get 1, and with alternating series, if you get anything other than 0, it diverges. Okay, error question again, so we need to plug our equation in. We get -e over, sorry, wrong button, over pi raised to the x. Okay, we go to the table. Okay, these are way too big. Let's back up and like try 10, 20, 30, 40, 50. Okay, looks like it's going to happen somewhere between 40 and 50. So let's back up here and we'll do 43, 44, 45, 46, 47, 48, and then 49. Okay. So we're looking for the first time we either equal 0.001 or go under it. Well, that's still above it. We're looking at the absolute value. So with 48 is the first time we go below it. So we don't want to use 48. We want to use everything that comes before 48. Now this time the series starts at n equals 0. So we use 0 through 47, which is a total of 48 terms. Okay, which of the following series converges? Okay, going very quickly, this is a p series, power less than 1, diverges. This is a geometric, where the r is greater than 1, so that diverges. This is a p series with a power of 1, so it diverges. D converges, because it's a p series with a power greater than 1. D, which one converges? It's A, because it's a p series with a power greater than 1. The rest of these, looks like my letter's off there, sorry. This diverges, p series less than 1. This diverges, it's alternating, you take the limit, it's not 0. This one diverges because it's geometric with the absolute value of r greater than 1. Okay, which one diverges? This one converges, p series greater than 1. This one converges, it's telescoping, and telescoping always does. This one diverges, it's alternating, and if you take the limit without the -1 part, we get 8, and that's not 0, so this diverges. D converges because it's a geometric where the r is less than 1. So the only one that diverges is C. 9, which one diverges? Well, this one converges because it's a p series power greater than 1. This one converges, it's geometric with r of less than 1. This one we could use the ratio test on, and I'll tell you it converges. This last one we use the nth term test. The limit is 2/5, which with the nth term test means it diverges. So our answer is D. And finally, number 10, the sum of the following series. You will have to factor this and do partial fractions and work that out. I believe this is worked out in my other video. If not, I'll add another one. But your answer should be, I believe your answer for this one should be 1 when it's all worked out. I believe you'll end up with this as your series, and then once you expand, you'll get something like 1 over 1 minus 1 over 2 plus 1 over 2 minus 1 over 3 plus 1 over 3 minus 1 over 4, and so on. So everything cancels out except for the 1. Okay, good luck, guys.